video, I want to look at the idea of sampling distributions. And in order to do that, I'm going to start with an example. Let's suppose we have a professor who gave an 8-point quiz to a really small class of 4 students. Let's suppose the results of this quiz were 2, 4, 6, and 8. And for the sake of this discussion, let's assume that this is the entire population for this particular data set. In this case, we can easily find the mean to be 5. And we can also calculate the standard deviation to be approximately 2.236. Now let's take a little bit closer look at this. I want to start by thinking about all of the samples of size 2 with replacement. So I want to look at all the ways I can get groups of 2, but I am allowed to pick the same person twice. I'm going to start by assuming I pick the person who scored a 2 first. Then for my second person, I could pick the 2, 4, 6, or 8. So I have 4 samples for that. Next, let's start by assuming we pick the person who scored a 4 as our first selection. Then our second selection can once again be 2, 4, 6, or 8. So far I have 8 different examples of samples of size 2. Picking the person who scored a 6 first, I have another 4 groups of 2. Finally, picking the person who scored an 8 first, I have a final group of 4 different samples of size 2. And these are all of the possible ways to get samples of size 2. The next thing I want to do is calculate the mean for each of these samples. I went ahead and calculated each of those means and wrote them all down here. So this is the start of my sampling distribution. This is all of the possible samples of size 2, and I have all of their means. Equivalently, I could pick all of the samples of size 3 and create a sampling distribution for that. But the idea is to pick a size for your sample and then take all of the samples of that size. Now, I want to calculate the average of these means. So I have kind of 2 groups, and I want to find the average of those. If I were to add up all of these numbers, 2 plus 3 plus 4 plus 5 plus 3 plus 4 plus 5 plus 6 plus 4 plus 5 plus 6 plus 7 plus 5 plus 6 plus 7 plus 8, and divide by 16, I get 5. And I denoted that by mu of x bar, since it is the mean of the sample means. And this was the exact same mean that I got for my original data set. I can also calculate the standard deviation of all of these, and I will not go through all the steps. We can use calculators to find it for us. But when I do, I get approximately 1.581. And this is not the same standard deviation of my original data set when I just had the original 4. So the mean did match, but the standard deviation didn't. However, if I take the original standard deviation of just my 4 numbers, the 2, 4, 6, and 8, that was 2.236. And if I divide that by the square root of 2, I actually get the standard deviation of these sample means. And this is the idea of a sampling distribution. For a sampling distribution, I'm going to start with a population with mean mu and standard deviation sigma. I'm then going to pick a sample size of n, and I'm going to take all of the possible samples with replacement of that size. For my example, I did size 2. And then I'm going to find their means. Then, if I look at the mean of all of those sample means, it will be the same as the population mean. And if I look at the standard deviation of those sample means, it'll be the original standard deviation divided by the square root of n. So when we talk about a sampling distribution, what we're really looking for are these values, the mean and the standard deviation. So if I have a population that has a mean of 75 and a standard deviation of 12, and I know I want to take samples of size 25, then I can find my sampling distribution. The mean is still going to be 75. That will not change. but my standard deviation will be the original standard deviation divided by the square root of the sample size, or 2.4. So I'm able to find both the mean and the standard deviation of these sampling distributions as long as I know the mean and standard deviation of the original population and I know how big my samples are.